All right, so today we are going to talk about compound events. So when we have two events, A and B, there's a few different things that could happen. We could be asking a question about A. So they use union and intersection. We don't really need to use that language, but we have to realize what's happening in these pictures. So here, this one is A or B, right? This one, this highlighted area is if A is true and B is true. This one is going to be if we have A or B and there's no sort of overlapping here. So what we want to focus on is how to find today we're talking about the probability of A or B. Previously, we were talking about finding the probability of A and B. So, um, two events are overlapping when they have one or more outcome in common, as shown in the first diagram. So here, if we were to say A or B, like these both have this overlapping area in the middle, those things are going to be called overlapping. Okay, so these two are overlapping. That should really all be one word. And then if they don't have anything in common, these circles never overlap, there's nothing that's A or B, then this is called disjoint. And you may also hear the phrase mutually exclusive. All right, so depending, we have rules based on when things are overlapping or disjoint. So the reason that the probability rules would be different is if you were looking at, if we were looking at this one right here, and we want to find the probability of A or B, this middle side is being counted twice. It's being counted for A and it's being counted for B. Whereas this one, it's just this A or this B. So the probability, if A and B are two events, then the probability of A or B is written as P of A or B is the probability of A plus the probability of B minus the probability of A and B. So we're going to use this rule right here when our events are overlapping, because there's some middle part here where A and B is true, and we would be counting that twice. We don't want to, so we're going to subtract it out. The other one is if A and B are two events, and the probability of A or B can be written as the probability of A plus the probability of B. This is going to be the one that we use if our events are like this, if they are disjoint, or you could say mutually exclusive, because there's nothing in the middle, so there's nothing that we're going to need to subtract. So this is what we're going to be talking about today, is how we find the probability of ORs. And we're going to do a few examples, but again, last time we really talked about and. So what's the probability of you rolling a 6 of this die and uh, spinning a spinner at green? This one is going to be or. And so with and, we multiplied. With or, we're adding together. All right, let's do a couple examples. All right, so we have a couple examples here. All right, so it says a card is randomly selected from a deck of 52 playing cards. What is the probability that you pick a 10 or a face card? So this question does require you to have knowledge of a basic deck of cards. So when we have a deck of cards, we have 4 suits, and each suit is going to have 110. So those each have 110. And then for face cards, we could have an ace, a king, a queen, or a jack. So that means that each suit is going to have 4 each. So those are kind of the important things that we need to know. So this is an or statement. And you need to think about, is it possible that you have a 10 and a face card, would those overlap? Those would never overlap because a 10 could not be a face card because our face cards are always ace, king, queen, jack. So that means that this is going to be disjoint, which it does say up there. But so since it's disjoint, there's no overlapping. All we have to do is find the probability of A and the probability of B and then add them together. So the probability of A is going to be that you have a 10, and then the probability of B is going to be that you have a face card. So we're going to have the probability of A or B is going to be equal to the probability of A plus the probability of B. All right, so let's tackle this one at a time. So what's the probability of A? What's the probability that you get a 10? Well, we have four suits, and each of them is going to have 1 10. So that means that we have 4 10s total out of 52 playing cards. So the probability of A is 4 over 52. And then plus the probability of B. Probability of B is having a face card. So we know that we have 4 suits and each of them has 4 face cards. So 4 times 4 is 16, so we'll have plus 16 over 52. So if we add those together, we will have 20 over 52. So that is the probability that you would get a 10 or a face card. For your assignments on Schoology, I need you to turn this into a percentage and then round to the nearest decimal or nearest whole number, I believe is what it says on the assignment. So I do 20 divided by 52 times 100. All right, let's look at our next one. A card is randomly selected from a standard deck of 52 playing cards. What is the probability that you have a face card or a spade? All right, so let's think. We know that we have 4 suits, and we know that we have 4 face cards. We have ace, king, queen, jack. So, sorry, I didn't mean to write suits. I meant to write 4 each. Okay, so we know that for face cards, like the last problem, we would have 16 of them. And then spades. How many spades do we have? Well, so there's our first, here's our second thing. For spades, you might know that it's 13. If you don't, you could just think you're going to have 1, 2, sorry, you're not going to have 1, you're going to have ace, 2, 3, 4, 5, 6, 7, 8, 9, and a 10. And then you're going to have a jack, a king, and a queen. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 13 possibilities. So now it tells you right here that this is overlapping, but you should be able to recognize that this is overlapping because it is possible for you to have a face card that is a spade, right? So that would be this one, this one, this one, and this one. Here, you could have an ace of spade, a jack of spade, a king of spades, a queen of spades. So that is why this right here is going to be overlapping. So we can use the formula for overlapping. So it will tell us that P of A or B is going to equal to the probability of A plus the probability of B minus the probability of A and B. Okay, so again, I kind of already labeled this, but the first one is the probability of A, the second one is the probability of B. So the probability of A, of having a face card, the probability of having a face card, we already found over here, but it's these 4 things times 4 different suits, so we would have 16 over 52. Plus the probability of B. The probability of getting a spade is going to be 13 out of 52. But there would be some overlapping, right? Because you could have a ace of spades, king of spades, queen of spades, jack of spades. So minus the probability of A and B. and that is going to be these four particular items here. So minus 4 over 52, and then I just combine them. And when I combine them, I'll get 25 over 52. All right, so these are how we find the probability of disjoint events and overlapping events. We've got one more example for you.